Imagine you're lost. You have no battery on your phone. You can't use Google Maps anymore. What do you do to get back to camp, to get home? You need to be able to read maps and understanding all the tools existing to get from a point A to a point B. This video is supposed to help you when that happens. More than that, to help you plan your trips and your hikes. So really, we're gonna ask, what is map reading? What is a map? How do you read a compass? And why it's so important.
A map represents the Earth at different scales, showing different things depending on who uses it and what they want to convey. Map reading basically is defined as the ability to make judgments about position in a 3D large-scale space from information presented in a 2D small-scale representation of the space, according to N. Brewston and L. Arquidolland. As the Australian landscape has an abundance of landforms, ranging from mountains and plateaus to bays and canyons with pristine waterfalls, one may wonder, which map would be the most suitable to use? We believe topographic maps as they accurately indicate elevation and slope of a landform. The focus today will be on topographic maps for their multifunctional purpose, from recreational like hiking and traveling to governmental like urban planning and urban management. It demonstrates a detailed physical appearance of an area's features.
In 2014, 3 researchers won the Nobel Prize for their research on the so-called brain GPS. Their names were John O'Keefe and the couple Maybrit Moser and Edward Moser. They won the prize because they found brain cells, called the place cells and the grid cells, that enable us to orient ourselves in the real world. This research is closely linked to the subject we're talking about today, which is the ability to read maps. There has been a lot of research on the map reading ability, namely why some people are better at it than others, and if it's possible to improve your map reading skills. Professor Amy Loban, a map reading researcher at the University of Oregon, has found that there are differences in the brains of people who are good at reading maps and people who lack that ability. In her mission to figure out why people's abilities in reading maps vary, she has discovered that people who are not good at map reading have a higher amount of activation in the front lobe of their brain than those who are good at it. In addition to this, Professor Nora Newcomb of Temple University and Professor David Hutton of Northwestern University reviewed 2017 research studies on education and spatial thinking. Their aim was to discover if spatial thinking and thus reading maps is trainable. Newcomb stated as a conclusion to his research that people of all ages can improve all types of spatial skills through training periods. In the study, researchers found that diverse methods can train one's spatial thinking ability, such as by using 3D representation and by playing video games. Different forms of training can be highly successful. Loban discovered 3 apparently trainable spatial skills that were key to map reading. Specifically, her definitions for these skills are the following. 1. Self-location, which is defined as the ability to relate where you are in the real world to the corresponding spot on the map. 2. Route memory, which is your ability to remember from a map the route and objects along the route. 3. Map rotation, which involves mentally rotating a map when you take multiple turns without having to actually rotate that map. Also, the place recognition and wayfinding skills are particularly important. As Newcomb and Utel have found that this graphicacy is indeed trainable, the following will introduce you to the basics of maps, its elements, reading a map, and understanding the compass. We are going to illustrate this by using the Bundanon area topographic map. Firstly, a legend is a list of the map's features and its corresponding symbols. A scale is a relation between an object's real size and its size on a map, model, or diagram. Coordinates are a pair of numbers and or letters that locate a point's exact position on the map. Points can be described as true north, being the direction of the North Pole, the grid north, being the direction northward along a map's grid lines, and the magnetic north being the direction indicated by a magnetic compass.
Nevertheless, there are also elements of a topographic map, namely geographic reticle, coordinate grid, and bearings and contour lines. Bearings help an individual to understand direction on a map, specifically their position relative to a starting point. On the other hand, contour lines are lines that connect points of an exact elevation. These lines never cross and occasionally form closed circles to depict the highest levels and lowest points, such as mountain tops. Looking at them, you get a good sense of what the land looks like. Index lines are the contour lines that are darker and give us the exact elevation. Specific details and contour intervals and index line in the legend. Here they are more close together, showing a steep slope. Here they are far from each other, revealing a gentle slope and form smaller circles showing peaks and hills. You can spot streaming water as it forms V's. The tip of the V shows the source. Check out maps, dates and magnetic information before using a compass.
So you need to know the different parts of a compass. The base plate, to introduce it to use with the map. The edge is to take bearings. Rulers to calculate distance. Direction of the travel arrow. A rotating bezel. The index line where to read my bearing. And inside the compass is a magnetized needle which always points the magnetic North Pole and not true North Pole. So orienting area, orienting lies to line up the compass with north. One thing to do is to set declination. That means the angle of difference between true north and the magnetic north. To do so, have a look at the legend for the declination diagram, along with recent revisions. If not, look on online current declination. Put this information in the compass. The magnetized needs to line up inside the orienting arrow, and then you'll have true north. Once declination is set, find your current location. Set your compass so that the straight side of the base plate lines up with your position. Find the point you want to head towards. Rotate compass until you form the line between where you are and where you want to go. Make sure the direction of the travel arrow is pointing in direction of the landmark you're aiming for. Then turn the bezel until the orienting lines are lined up with north on the map. Then look at the index line to read your bearing. Then let go of the map, align the needle and the orienting arrow, and off you go.
In addition to this, one may argue that the quality of maps may form another issue in the current world. Firstly, the issue in terms of misrepresentation lies a lot closer to home than what we expect, as just last week the Cross River Rail failed an assessment by Australian infrastructure for including errors such as the incorrect mapping of Brisbane by placing the CBD on the opposite side of the river. Or imagine that the map we have been taught to use our entire life, the 500-year-old Mercator projection, is actually a misrepresentation of the actual size of the globe's countries. Did you know that Canada can actually fit 3 times comfortably into Africa? In fact, it's even large enough to fit Mexico, China, the States, Europe, India, Japan, when one rotates the countries around. One may wonder how this is possible. Well, translating a 3-dimensional to a flat shape creates rooms for errors, specifically when parallels and meridians are kept as straight lines, resulting in false country shapes and sizes. But what are the other reasons why a country may be enlarged on maps? Firstly, this allows Western cartographers to have more space to mark their own cities and roads, in keeping with the academic finding of Golich, who found that the more a subject is familiar with its environment, the greater the accuracy of the location's estimates. Additionally, the bias may also be attributed towards political reasons, as larger countries appear more powerful and intimidating towards others. Furthermore, according to Barnes and Duncan, countries such as Russia have also admitted towards falsifying their topographic maps in order to confuse the enemy.
Therefore, debates have sparked whether it is time to remove bias within the education system, and thus to replace the universal reliance on the Mercator projection with a map that depicts the true size and shape of the world's countries. Yet, the question arises whether this will even be possible, as this projection is so ingrained into our geographical lives like in Google Maps, whether a perfect map even exists. The quality of maps can also be analysed in terms of map incompleteness. Consider that in 2005, only 15% of the world was mapped accurately. This deemed a large problem when natural disaster Nargis hit Myanmar in 2008, which increased the urgency of creating detailed maps so that help services could intervene. These maps were created with Google MapMaker for crowdsourcing, as users were mapping their local knowledge. Yet the solution arose the risk of human error altogether. Interestingly, the solution to improve maps dates back to 1984, according to Barnes and Duncan, in which 700 individuals. Lastly, one should be aware that maps are not always accurate. Various maps in the past have included non-existent islands, seas, mountain range, and even countries. which all have been debunked in The Phantom Atlas by Edward Brooke Hitching. Although this seems like an unimaginable thought for the 21st century, men are still exposing fictional locations. For example, the alleged sandy islands between Australia and New Caledonia was actually confirmed to be non-existent in 2012.
So what is the ideal type of map to use in order to minimize errors and misrepresentations?
Harris found that although cartograms are common for displaying geographical information, especially when locations are too small for the map scale, they are prone to geographical distortion as a result of distributionally skewed data. Supporting this finding, Elder found that geographical distortion can be minimized with topographical maps if grids are used. This is namely because grids help individuals give structure for clustering visual map data, as well as finding coordinates. Next time you're in the Blue Mountains, don't run the risk of your smartphone dying or your network failing. Bring along one of these maps. After watching this video, you're now ready to explore the Australian landscape. Have fun!